Welcome back. This is the first lesson recording for IM2, April 12, 2021. Before we begin, I want to quickly reflect on where you are right now. We are entering into the last 7 weeks before this challenging year is going to end. And where are you in terms of school, in terms of math, in terms of life, really? Okay, and life really is just you're making many steps, many choices in life. Are you feeling like you can't do it? Or do you feel like, are you at a point where you can say that, how do I do it? I'll try to do it, or I can do it and I will do it. And yes, I did it. So I hope as you face challenges in life that you are going to rest on your resilience and resourcefulness to conquer any obstacles that comes about, because I assure you, you are going to come across many unexpected struggles in life that you're going to have to face and conquer. And at the end, you're going to come out stronger than you were before. And that is the goal. All right, some announcements. IM2 study hall tutorial. We used to do it on the same day as the math classes, but since the schedule change, we are going to change the study hall tutorial time to B days from 10:20 to 10:50 a.m. So that means after you go through the math lesson, you try to complete the homework on the A day, afternoon or in the evening. Try to do it that night so that your memory is fresh, as well as you can tell whether you are able to complete the homework on your own or whether you need help. If you find yourself you're getting stuck or you're unclear about some of the content, then you should be attending the study hall the next morning at 10:20 to 10:50 to get help and clarification. Where have you been? We have just covered interior and exterior angles in polygons and also area and perimeter of special polygons, such as parallelogram, trapezoid, triangle, and rhombus. So today we are going to be covering the area of any polygon that is regular. So to start, let's answer in private chat. All figures are regular that I'm going to be showing you, which have enough information to find the area. What do you think? Okay, so if you have this, okay, do we have enough information to find the area of this 1, 2, 3, 4, 5, 6, 7 septagon? Do we have enough information for that? We are given the one of the side length is 10. We're given the distance from the center of this septagon to the perpendicular distance from the center to the side is 10.4. Do we have enough information? What about B? Okay, this time we have pentagon, 5-sided polygon, and we're given the side length of 4.7, and we're also given the distance from the center to one of the vertices to be 4. Do we have enough information to figure out the area of this pentagon? Okay, what about this octagon? This time we're just given the distance from the center, a perpendicular distance from the center to the sides, or lastly, just the side length of a pentagon. Do we have enough information? Well, believe it or not, we do. In all of this, we can figure out the area of each of these regular polygons just with the information given, and hopefully by the end of the class, you'll be able to do it yourself. Before we begin, we're going to work on some vocabulary for regular polygons. So the radius, you're familiar with radius in circle. Well, what is a radius in circle? It's the distance from the center to the outside circumference, right? So for radius of a polygon is the distance from the center to the vertex of a polygon is called the radius. What's the central angle? it's the angle formed by the two adjacent radii. So if you have, this is one radii, this is another radii, this is another radii. Okay, so you have two radii here, and the angle formed at the center is what we call central angle. Okay, apothem is a perpendicular height from the center to the side. So perpendicular, that's from the side. If you were to draw a line that is perpendicular, that makes a 90 degrees to the center of the polygon. That's what we call apothem. Right, so we are going to be exploring area of a regular polygon level 1. And to do that, you're going to be working on Desmos card number 1, 2, 3. So first card, draw in all the radii of this regular octagon. How many radii are there? Okay, so it's octagon, that means there are 8 sides. So how many radii are there? Let's draw them in first. Okay, so radii is from the center to the vertex. So we can draw a line from like this and another line from here, another line from here. So these are each radii of this octagon. Okay. Color in two central angles in this regular octagon. Okay, so now that we have drawn our radii, we need to color in two central angles. Well, central angles are made by the two angle formed at the center by the two radii. So that's going to be, this will be one, and say this will be another. Okay, but each one of them are all central angles. This is a central angle, they are all central angles. So how many central angles are there? There are 8. Because there are 8 radii, that also means we have 8 central angles. And what is the measure of each central angle? Okay, what is the measure of each central angle? Well, we know that the whole revolution is 360 degrees, and we have 8 equal angle because the sides are the same. Okay, the sides are the same. That means the central angle has to be the same for all 8. So it's going to be 360 divided by 8, which is going to be 45 degrees. So we know that each of the central angle is going to be 45 degrees. Okay, and then color in 2 apothems in this regular octagon. So how many apothems are there? So apothem is when you're drawing a line, perpendicular line from the side to the center. A perpendicular line from the side to the center. And this is like so. Okay, and to mark that they are perpendicular, I am going to put my perpendicular notation here to say that they are all perpendicular line to the side. Okay, so and how many apothems are there? We have 8. Okay, great. Now you're going to try to figure out the area of this pentagon. Okay, so we are given this 15.4. That's the apothem. That's the distance from the center to the perpendicular line drawn from the side. Okay, so perpendicular distance from the center to the side is 15.4, and we're also given that the one of the side length is 22.4. Can we figure out the area of this pentagon? Well, you have two options. I don't think there is enough information to find the area, or I have some idea. Here's what I got so far. Okay, so wherever you are, you can just answer. Okay, just say, I don't understand. I don't know how to do it. Then I can just click on that and I can just say, I don't know where to begin, or I don't see how I can create area with this information. Okay, Samir sketched the diagram on the left below in his work to find the regular pentagon's area. So this is the same pentagon as before, but this is Samir's work. What did he do? He first figured out the area of this triangle. Notice that this triangle is going to be congruent. We're going to have 5 congruent triangles to this white triangle exactly, because we're talking about five pentagon, a regular pentagon with each of the sides having the same length, right? So if that is the case, can we figure out the area of this triangle? Well, we know that this, we're given that this is 15.4. That means we also know that since the side lengths are the same, I know that this is going to be 22.4. Okay, so if this is 22.4, what is and the height of this triangle is 15.4. Okay, so what is the area of a triangle? It's half times base times height. Okay, so the triangle is going to be half times base is 22.4 times 15.4 is the height. And this gives us the area of one triangle to be 172.48. So the whole pentagon, we have 5 congruent triangles that forms the pentagon together. So it's going to be 5 multiplied by 172.48, which is going to be 862.4. Okay, and you can answer whichever one applies to you. Okay, so hopefully at the very least you understand this work. Then you are going to go on to solving this problem yourself. Okay, now this time we have a heptagon. Heptagon is a 7-sided polygon. Use the same method as Samir to see if you can um, figure out the area of this heptagon. Okay, so to do that, sketch in all the radii. How many congruent triangles are formed? So I am going to start by drawing in all the radii. Oops. Okay, so how many congruent triangles are formed? Let me just get rid of this. Let me do another better one. It should be 1, 2, 3, 4, 5, 6, 7. 7 should be formed. It's a 7-sided polygon, so there should be 7 congruent triangles. What is the area of each triangle? We're given this apothem length is 10.4. We're given the side length is 10. That means we also know that side length of the base of the triangle is also 10. So to calculate the area of this one triangle is going to be half times, so that's going to be 0.5 times, okay, what is the base? That's 10. What is the height? 10.4. Okay, and that's going to give me 52 as my answer. Okay, so then what is the area of the heptagon? So we have found one area, one triangle is 52. So it's going to be 52 times 7. There are 7 equal triangles, so that's 364. Great. Now you're going to go on to taking notes here. So area of a regular polygon is going to be area of one triangle times number of triangle. And to figure out the area of one triangle, we can just create one triangle, and that's going to be, how do we figure out if it's going to be the side length times apothem? times half. That's going to be one of the triangle. The number of triangle is going to be the number of